Welcome to Rice 101 module number 14. My name's Griffiths Atungulu. I'm the director of the Hawkins Rice Processing Program. I'm an associate professor and an agriculture engineer. My area of specialty is in grain processing and post-harvest systems engineering. I'm housed in the Department of Food Science, the University of Hawkins System Division of Agriculture. In this module number 14, we are going to look at end-use processes for rice, and then we're also going to look at some value-added products that come from processing rice. From an end-use processing standpoint, we are going to cover some basic end-use processes, starting with parboiling, instantization, fortification, and then we're going to look at extrusion. And then after that, we're going to discuss some of the value-added products from rice and rice processing byproducts. So let's begin with end-use processes. As I mentioned, we'll start with the parboiling process. Now, parboiled rice is typically rice that is partially boiled in the husk and dried, and typically it produces grain that cooks separately and fluffy. They're very, very popular in the food service industry. And in some countries, about 50% of the paddy is parboiled. In the US, our market is slightly less than that. We don't parboil a lot of our rice. And you can see images there that show some of what you might see in the market. Now, the parboiling process basically starts from the moment we receive rice from the field. We can either directly dry that rice, or we may take that rice through a cleaning process, and in a parboiling scenario, that rice goes through a soaking process. So the rice is soaked in hot water, and then it is steamed, and then after steaming it, it is dried and then milled. And there are various advantages as to why we do this. One of the key advantages that it tends to result in a nutrient-dense milled rice. It tends to change the texture of the kernel. It tends to increase the head rice yield, and essentially produces a high-value product compared to non-parboiled. And we are going to see a description of how some of this happens in the next slide. And so what you see here is now what we call the steps of parboiling and how it eventually leads into a high-value milled rice. First of all, as I mentioned, when that rice comes from the field, it is soaked. And during the soaking process, warm water makes the vitamins and the minerals to become more soluble, and then they move out of the bran into the endosperm. Now, the bran is that part of rice that we have just beneath the hull, and so that bran is rich in various minerals and vitamins. And the purpose of this soaking, again, is just to make sure that those vitamins and the minerals are made to be soluble, and they are able to move with the liquid or the water into the endosperm. Then we have the next step, which is the steaming process. In the steaming process, as you can see in that image, hot steam and air pressure move those nutrients that were in the bran into the endosperm. And then once those nutrients have been moved into the endosperm, they have been removed out of the bran. When you go about now removing the bran, you are actually reserving those nutrients within the endosperm. And so typically the final product carries about 80% of nutrients in a brown rice that has been parboiled compared to one that has not been parboiled. End-use processing that I want to describe is instantization. As the name suggests, this is a process that is used to produce instant rice that can be eaten pretty much without taking a significant amount of time to cook it. So instant rice is that rice that has been pre-cooked and is microwave ready. And in typical scenarios, it requires very less time to cook. Now, regular rice would take about 18 to 30 minutes to cook, while instant rice, because of the process that it goes through, it requires about 1 to 7 minutes. Now, there are cases where it is dehydrated, and when it's dehydrated, typically you require some water to reconstitute it, and then that water, as long as it's boiling water, will reconstitute it and make it ready in about 5 minutes. Now, the process of producing instant rice starts with blanching that rice and then steaming that rice. rinsing it to remove any starch that has leaked out of it that would cause any stickiness, and then take it through a dehydration process if it's going to be a dehydrated product. Now, the basic principle is to increase the moisture of the milled white rice with water to form cracks within the kernels. And then once those cracks have been formed, it enables the faster cooking of that rice kernel when it goes through the microwaves. I want to describe what an industrial drying process for an instant rice would look like, because this is one of the most energy-intensive processes. Typically, once that rice has been cooked, you use heated air, which is about 135 to 195 degrees Celsius, to dry that rice. So the pre-cooked rice is typically placed on a conveyor belt, and then as it moves through some drying zone, the air is removed. That air is being forced through the cooked rice at some given velocity, and when it comes out, it's then cooled, and we have ready-to-go instant rice. Now, another end-use process that you'll find in the industry is rice fortification. And so rice fortification basically is the deliberate increase of the content of some essential micronutrients. As you'd imagine, there are some countries that use rice as their predominant or their staple food. And rice, as you know, contains majority of it as starch or carbohydrates. And so for them to get other nutrition, they may have to add some other micronutrients. And so this process improves the nutritional quality of this rice. It provides additional health benefits to the public uses, and it's practiced in several countries, as I mentioned, that use rice as a staple food. Now, there are various processing options for fortifications. Number one, we can add micronutrient powder that adheres to the grain surface. Or we can spray the surface of the grain with the vitamin that we need, or the mineral mix that we need. And that mineral mix or the vitamin would kind of form a protective coating on that surface. On the other hand, we can also do an extrusion process where we would blend our micronutrients with the rice, and then do an extrusion process and get a fortified end product. Now, the commonly fortified micronutrients include things like iron, folic acid, and other B-complex vitamins, vitamin A, as well as zinc. Now, extrusion is one of those very, very important end-use processes that is out there that's being used to add value to rice. And basically, this is a process by which rice is moistened, and then it is made to expand. And basically, during the process, it plasticizes, and then that happens because of the pressure and the heat that is added by the mechanical shear energy of the extruder. Typically, you can end up with extruded products that can have various shapes. For example, in the industry, we have actually extruded rice, and these are made from rice flour. It could be from broken rice flour that can be passed through these extruders to come up with kernels that really mimic the shape characteristics of the natural rice. For example, you see in that image an extruded rice versus a natural rice. In the market, you can find various extruded rice products. If you look at this image, the first image there are actually extruded rice kernels, again, starting from broken rice, turning this into powder or into flour, and then that is passed through an extruder to kind of come up with kernels with shape characteristics that mimics very, very closely extruded rice, very, very closely kernels that are natural. And we have brown rice pastas that are made through an extrusion process. And we also have extruded rice puffs that can be found in the industry. Of course, the pet industry is using a lot of broken rice kernels in their pet food manufacturing, and you can see some of the extruded products that are made from rice flour using an extrusion process. Let's talk about some of the value-added products or rice processing byproducts. To start with, let's start with the rice husk. As you know, when rice goes through a milling process, we have to remove that rice husk. And so how can we add value to this? Now, in the industry, this has found some application, production of rice husk biochar. This is done through a pyrolysis process that basically involves a thermal degradation process. In the absence of oxygen, they produce gas, tar, and char, and we end up with producing rice husk biochar. These have been traditionally used in some places, even as soil amendments, but most of the time we can use this to generate energy. Then there's the other byproduct of rice processing, and that is the rice bran oil. Again, very, very precious product from rice milling processing, and this is basically a co-product of milled rice. Rice bran oil composition has some amount of saturated fatty acid, also some monosaturated fatty acid, as well as some polysaturated fatty acid. Now, from a health standpoint, it's touted as one of the healthiest oil in the world, but in the US, it has really not reached its full potential of utilization. Now, there are cases where the rice bran has been used as it is in the animal feed industry. As we know, it contains lipids a lot, and it's a very useful source of energy. Has been used as an ingredient for broiler chicken. It also has been used in livestock feed systems. Now, defatted rice bran tend to have higher fiber content after removing the lipids. Again, it's known to have high content of linoleic acids, which are very, very important in animal feed sector. Now, there are other products that we can get from broken rice. For example, we can get starch extruded from that or isolated from that, and that starch can be used as a thickener in the gravy production. We also can use that rice starch in cosmetic industry. We can use that rice starch in the textile industry. Directly, we can also use that broken rice flour in the rice flour production industry. We can use that also to produce noodles and a myriad of other things, for example, in the pet nutrition world. And so broken rice, the byproduct of the rice milling system, has found various applications as well. Then we also have liquid glucose that has been produced from broken kernels. These are basically an aqueous solution of saccharide that is obtained by a starch hydrolysis process. It's typically odorless, it's clear, and yellow colored sometimes, and has a viscous sweet syrup. And so that image kind of shows what liquid glucose would look like. And this is a byproduct, again, from broken rice. Then, of course, we have rice beer. Rice beer is produced from the brewer's rice. That image there kind of shows you brewer's rice, but sometimes also produced from large broken rice, or can also be produced from just whole kernels. So rice has found an application as an adjunct in the brewing industry. Now, brewer rice quality is determined generally by the cleanliness, gelatinization temperature, the mass viscosity, the mass aroma, the moisture, the oil, the ash, and the protein content. And the rice tend to have lower oil content compared to other cereals or grains, which is an advantage from a beer production standpoint. Now, rice structure, again, compared to barley, it tends to be a little bit more granular. And then the only other thing is that rice is low yielding in terms of brewer extract. Again, that's due to the grain size. We are familiar with Budweiser. This is one of those beer that is produced from rice. It's brewed using various ingredients, and again, rice is a major adjunct in the whole process. Now, rice beer has a neutral aroma and flavor with a light, dry, clean tasting, and kind of attached to it compared to other beers. And so with that, I want to leave you with these references that you can look at and glean a little bit more information in terms of what I've talked about today. And I want to say thank you very much for listening, and I look forward to talking to you in the subsequent modules.